In this lesson, we're going to look at how to decompose rational functions with irreducible distinct quadratic factors in the denominator. I want you to take note of quadratic, and I want you to note from algebra 2. This quadratic equation here. See the difference of two cubes. This is how we factor it. I want you to know the quadratic factors in the denominator. So how do we do this one? To do this one, we just follow the same steps. We start by factoring the denominator. So the numerator is 8x squared. So 8x squared plus 5x plus 18 over, I factor the denominator using the rule I have there. So this becomes x minus 2. Then we have x squared plus 2x, and then plus 4. Okay, so that's what we have. Now I'm going to rewrite this using I'm going to write it using the a. I want to break it down. So this will be a x minus 2. See, something is a little different about this case 3. So this becomes bx plus c. That's just the rule. Just follow this rule. That's how to break it down. And then we write the quadratic factor here. So this is 2x plus 4. So note what I put as a numerator in the quadratic factor. Now I'm going to do all this work right here. So see, the first one needs to be multiplied by a. I need to multiply by, so I have a, I multiply by the quadratic factor because it's missing in the denominator. So x squared plus 2x plus 4, and then plus, see, the second one is missing x minus 2. So I'm going to multiply by x minus 2, and then here we have x squared plus 2x plus 4. And because I know the denominator is going to be the same in both cases, I'm just going to write this as equal to the original function, which is 8x squared. So I'm just going to ignore the denominator, and also because I don't have much space right here, but the denominators will be equal on both sides. And what I'm saying is this denominator is the same as all that. So I just equated those two equations because they have the same denominator. So now the work is on this side because we need to multiply it. So ax squared plus 2ax plus 4a plus, I multiply this out, and you can do this by, you can make a table, or you can just multiply it out. And when you multiply it out, this is what you're going to get. I'm just going to write it down. I multiply it out on the side, and when I did that, I'm just looking for where I wrote it down because I don't have much space to write it here. When I multiply it, so this is case 3. So when I multiply it, I get bx squared. what happened to the B? Oh, I forgot to write the B. So this is B right here. So again, and I'll just write it in yellow so that you can be able to see the difference here. Bx squared minus 2bx plus cx minus 2c, and all this is equal to 8x squared plus 5x plus 18. And I just want to point out, see, all this, when it's multiplied, gives me all that. And now the next thing I'm going to do is to combine the like terms. So I combine the like terms. So I'm going to do ax squared plus bx squared. I'm just identifying them and putting them together. And then I have the ones with x. So I have 2ax minus 2bx. And then what do I still have? I still have, and then I have the plus cx. I shouldn't forget that because that one has an x also. And then let me go to the constants. Plus 4a, the ones 4a minus 2c. So this is all equal to that. Okay. And I'm not going to write that down because I need space here. So here, what do I have? I'm going to write a. Let me do the x squared. Let me write in parentheses a plus b x squared plus, then I'm going to factor the x out. So parentheses 2a minus 2b plus c x, then plus 4a minus 2c. And I'll just take time to check it. So I have a plus b x squared, and then I have 2a minus 2b plus c x, and then 4a. And remember, this is all equal to, now I need to write my equation right here so that I can start comparing 8x squared plus 5x plus 18. Now what is common on both sides? I'll start with all that has to equal 8. So that means a plus b is equals to 8. Because both of them have a coefficient, have x squared. And then I'm going to go to the next one. See, all that has to equal 5. So that means 2a minus 2b plus c is equals to 5. And then these two, I'm going to use a different color here. Let me use a different color. So these two must equal 18. So 4a minus 2c is equals to 18. And here I have a system of equations. And this is where we apply matrices to solve it. So I'm going to write a matrix here. So this is, and I see I have three I have 3 variables. So this is going to be, I'm just going to write the coefficient matrix. 1, and then 1, 0, because there is no C. And this is going to 2, negative 2, 1. And this is going to be 4, negative, no, there is no B. So I'm going to put 0 instead of, and C is equals to negative 2. And now see this, it looks familiar to what we did the other day. Okay, so here this is going to be equal to 18, 5, and sorry, actually A plus B. See what I wrote here? I should have written 8. So just erase it. So that's 8. And this here is equal to 18. So that's what I have. And then here you use, I'm going to rewrite it. Remember, all I need to do to find A, B, and C. So A, B, C is going to be given by the inverse of 1, 1, 0, 2, negative 2, 1, 4, 0, negative 2, inverse, and then I multiply that by 8, 5, 18. And when I'm all done, I put that in the calculator. So you do that in the calculator. That's what I'm doing right now. And when you do it, this is what you should get. And I want you to try this in the calculator, because we did this when we were doing matrices. So A is equals to 5, B is equals to 3. Remember when we did systems of equations, C is equals to 1. Many steps, but that's how to do it.